Hi guys, so this is my project of phase 2 normal task from CODERS as a data science intern. So it's a email spam detection. So we all will be using the emails, right? So over there we'll be receiving a lot amount of mail. So you will be seeing a spam box. So over there will be all the spam messages. So the algorithm of the Google makes the separable or the classify the spam as well as the normal messages. Okay, so this will be a greater time saver for each and every one of us. So first, let's see the outline. So this presentation consists of the executive summary, introduction, methodology, conclusion, and finally the appendix. So the dataset is being obtained from Kaggle. The pre-processing has to be done for the NLTK process because it's a email spam detection. So the NLTK library helps in processing the data as well some of our own pre-processing too. So the title of the project is email spam detection, and the main motive of this project is to separate the email as spam or ham based on the text in it. Like you will be getting that message from the email, right? So based on that text, we will be classifying the email as spam or ham. And the main objective is to get a good accuracy as well as reliability that it is spam, not the ham message to be classified as spam. So then let's see the methodology. So data collection. So here the entire dataset has been collected from Kaggle as I said earlier. So here is a link, you can check it out, and the data wrangling process. So the data wrangling process is also called as data pre-processing or processing the data for some other purposes, for analysis or for to applying machine learning algorithm or normalizing the data each and every time. So similar. So the analytical libraries like stemming, TF IDF, vectorizing, and so on has been used here. So the data wrangling process includes the removing punctuations like the comma, full stop, question mark, quotations, and so on. Like consider a situation you are using the system, right? So it can understand only the binary values. So consider you are writing hello, comma, then you are writing I am something something. Okay. So this comma will also be considered as a separate thing. So without comma, the sentence will be taken as a separate one, like let's say x, and with comma it will be considered as y statement, like it's another statement. So we have to avoid such a critical situation for the system to be decided with. So we have to remove all the punctuations and the lowercase. You have to convert each and every text into lowercase. Like if you are writing the data wrangling, as you can see in the slide, I have written D and W of data wrangling to be uppercase, right? It's a capital letter. So if it's written in the small letter like D and W and all the letters are being written in the small case or the lower case, so the computer will identify these both words into a separate thing, like data wrangling with capital letter as some other word and data wrangling with small letters or the lower case with another word. So it's not a good practice, right? We'll be giving more stress on the system. So to avoid it, we have to convert these letters to be lowercase. Then tokenization. Tokenization is a term for giving each and every letter to a particular value. Okay. So the system can understand only the numerals. So we have to convert all those things into a numeral value. Then removing the stop words. The stop words contains the words like and, is, was. So it doesn't make sense, right? So consider the situation, I am playing. And let's take a situation, he is playing. So here I am playing is a thing that I am playing, and he is playing and he play. It's a good thing, right? Like if if you have to make the system to understand that a person is being playing, then he play. It's enough, right? We don't want to mention that whatever the tense is, like it's a present tense or present continuous or it's past or past continuous. It doesn't make sense for this classification of spam and ham. So we have to remove all those job words, and the last process is stemming. So consider a word called playing. So playing is similar to play, but it's not a continuous thing, right? So we just need a main thing. So play is enough, right? So consider a thing called carrying, CARING. So over there, if you do the stemming process, it will remove the ing and it will become car. Is it a relevant word for carrying? No. To avoid this situation, we can use another process which is called lemmatization, which is not being used here because it's a huge process and it takes a huge amount of computer or the system resources, and it takes a large amount of time than the stemming process. So here this carrying will be converted to char in the lemmatization process. But in stemming, it will directly remove that ing part and will return the car. Okay. Next, by using the count vectorizer, the entire sentence has to be tokenized, okay, and arranged in a particular manner. Then the algorithm, the grid set CV. So this algorithm is capable of doing a search using the cross validation for the given model as well as the hyperparameters. So here you can see the classification matrix. Over here, only two of the ham messages has been classified as wrongly as spam, and 90 of the spam messages has been classified as ham. So the ham message is a good message that is necessary for us, which is not a spam. Okay. Next, the conclusion. We found that the SVC with optimized and fine-tuned hyperparameters helps in training the model for the particular data set with more accuracy. So finally, we got the accuracy of around 97.9%, which is approximately equal to 98%. Next, the appendix. So here you can see the IPONB file of the project. So that's all, guys. Thank you. Once again, I would like to wish CODERS for providing me this wonderful opportunity to work as a data science intern to enhance and enrich my skills and ability. So thank you.